Dear students, in question number 17, we have given, so first of all, we have questions cos alpha plus sin alpha equals to over root 2 times of cos alpha, and have to prove cos alpha minus sin alpha equals to over root 2 times of sin alpha. So here it is given the sum of expression like a plus b is like over root 2 cos alpha, and then we have to find the values of like a minus b. So if we compare the first expression cos alpha plus sin alpha to a plus b, then in the proof we have to show like a minus b equals to something which is given in right hand side. We have to prove it. But only one thing you have to understand here. In the place of a you have cos alpha, and then in the place of b you have sin alpha. Okay. Now, so let's begin the solution. Here it's given cos alpha plus sin alpha equals to over 2 cos alpha, no doubt. And then have to prove cos alpha minus sin alpha equals to over 2 sin alpha. And then I have taken what I have given here, that is given cos alpha plus sin alpha equals to over 2 cos alpha is given, equals to cos alpha is given. So I have done here squaring 2 cos alpha dot sin alpha. So I have done squaring on both hand side on the given expression, on the given equation condition. So when we do squaring on both hand side, then you know there will be cos alpha plus sin alpha whole square is equals to over 2 times of cos alpha, and it's a whole square. So this expression is in the form of a plus b whole square. So we should expand it by using a plus b whole square formula, but in the place of a we should replace cos alpha, in the place of b we should replace by sin alpha. So after this I found cos square alpha is cos square alpha is a square plus 2 cos alpha dot sin alpha is 3ab plus sin square alpha is b square, and over 2 whole square is 2, and cos alpha square is cos square alpha. Then just I arrange the first terms and last term. I have arranged the first terms and last term at the same place. Arrange the first terms and last terms, then I have written them at the same place, and then I have written this middle terms at the end of this left hand side, and then copy its right hand side as it is. And you know that the sum of cos square alpha plus sin square alpha, it means cos square alpha plus sin square alpha is always equals to 1. So in the place of sum of cos square alpha and sin square alpha we should write the 1, and then 2 cos alpha dot sin alpha is as it is here, and then right hand side we have 2 cos square alpha, only 2 cos square alpha. I just copied it from this steps to this steps in as it is form. After this I move this 1 on right hand side, and it becomes minus 1 here on right hand side, and finally what we got here, 2 cos alpha dot sin alpha equals to, we got 2 cos square alpha minus 1, and later the value of 2 cos alpha dot sin alpha will be used on the given solutions. It means that the rest of the part of the solution. So later what we will do, we will replace 2 cos alpha dot sin alpha by 2 cos square alpha minus 1. So now, on the rest of the part of solutions, we have to discuss about some formula. Then we will go on the rest of the part of solutions. So dear students, if you have given a plus b something is equals to given, suppose if you have given a plus b, because suppose over 5 is given by the equations, and then if you need a minus b equals to what, then my dear students, we can express a minus b in term of a plus b. We can express it. I'm going to show it. Let's see. If we have written a minus b whole square is equal to in the form of in terms of a plus b whole square, then we can write a plus b whole square. We have to write it minus 4ab also we have to write it. So this is the formula of a minus b whole square. We can see it. We can prove it. You can see a plus b whole square is, you know that it is the square of a minus 2ab plus b, sorry, there should be plus minus 4ab. So after all, if we keep that a square and plus b square as it is, then tell me what is the subtraction of 2ab to minus 4ab. The difference between 2ab minus 4ab is minus 2ab. And you know that it is the formula of a minus b whole square. It is the formula of a minus b whole square. So that what I want to say, we can write the whole square of a minus b in terms of whole square of a plus b, but later we have to subtract 4ab. So in our questions, in the place of a we have cos alpha, place of b we have sin alpha. So if we replace a by cos alpha and b by sin alpha, then this formula becomes cos alpha minus sin alpha whole square is equals to cos alpha plus sin alpha whole square minus 4. A is cos alpha and b is sin alpha. This will be there. Why we use this formula? You know that we need cos alpha minus sin alpha. Because of that, to get cos alpha minus sin alpha, we use this formula. Later we will eliminate this square root and keep square root. Later we will eliminate this square from here, and then we'll keep over root on the right hand side after reducing this square from that. But if you want to write directly here, okay, I'm going to show you here. If you want to write here, listen, if you want to write here directly value of cos alpha minus sin alpha, you know that this square will be changed into square root on right hand side, and you can copy this all in as it is from here. So the formula of cos alpha minus sin alpha is equals to over root of cos alpha plus sin alpha whole square minus 4 times of cos alpha sin alpha it will be. So I'm going to show the solution of rest of the part. Okay, we're discussing about this. So here we know that a minus b whole square equals to a plus b whole square minus 4ab, and I already told you that in the place of a we have cos alpha, in the place of b we have sin alpha. Simply keep there. I kept it in the previous part, and when we keep cos alpha, in the a by cos alpha and b by sin alpha, then there will be cos alpha minus sin alpha whole square, and then equals to plus cos alpha plus sin alpha whole square minus 4 cos alpha dot sin alpha. Is sin alpha dot cos alpha. And what I did, cos alpha plus sin alpha has a value. It is given by question. You can see that here. Cos alpha plus sin alpha has a value. It has a value over 2 cos alpha. It is given by question here. So what I am going to do in the next steps, I am going to keep the values of cos alpha plus sin alpha by over root of cos alpha. So I replaced this cos alpha plus sin alpha by the given value over root 2 cos alpha, but its square is as it is, so I kept that square as it is form. And what I did here, I changed that 4 sin alpha dot cos alpha as 2 into 2 sin alpha dot cos alpha. Can we do it or not? Of course we can.
Yes, sir.
Of course we can do 2 into 2. We can break that 4 into 2 into 2. So, and if we keep the bracket here, we found the values of 2 sin alpha dot cos alpha on previous condition number I. Here you can see that I found the value of 2 sin alpha dot cos alpha equals to 2 cos alpha minus 1. So, and one thing, dear students, 2 cos alpha dot sin alpha and then 2 sin alpha dot cos alpha, it means same thing. So substitute its value. Yes, its value is equals to 2 cos alpha minus 1. So I substitute its value here, 2 cos square alpha minus 1 in the place of 2 sin alpha dot cos alpha. After that, over root 2 cos alpha whole square is there. We have over root cos square. After that we have over root of cos square alpha. So over root 2, over root is eliminated from over root 2, and cos square alpha is here as it is by cos alpha change into cos alpha by whole square, and minus, if we substitute its value from the condition first, then it will be 2 to the 4 cos square alpha, and this 2 multiplied to this 1 and minus, and this minus becomes plus, and it will be plus 2. Now 2 cos alpha, I have written this constant term 2 in front, and then the difference between 2 cos alpha minus 4 cos alpha as it is here, that is equals to minus 2 cos alpha. I have taken out 2 commands, and then after taking 2 common, then 1 minus cos alpha is left, and 1 minus cos square alpha is the formula of sin square alpha, so I kept 1 minus cos alpha by sin square alpha. After this, what we found, we found the values of cos alpha minus sin alpha whole square. Yes, whole square equals to 2 sin square alpha. So cos alpha minus sin alpha is always equals to whole over root. Yeah. If we eliminate this square from right hand side, sorry, left hand side, then there will be the square root in right hand side. So I have eliminated that square from left hand side, this square from left hand side, and then keep this square root right hand side. And you know, this over 2 does not have, it means that 2 is not in square form, so we just write that 2 as it is, but sin square alpha is already in square form. This square eliminates its square root and becomes sin alpha outside of square root. So I have bring out, you know that I bring out that sin alpha from the square root, and finally what I got here, I got cos alpha minus sin alpha is equals to over root times of sin alpha, which we need in a proof. So this much on this question.